So today we're going to continue our process with multiplying polynomials. In fact, we're going to pick up exactly where we left off yesterday. So this is just part 2, but ties into exactly what we were doing yesterday. So let's say we are given 2y minus 7 times 2y plus 7. So we have a binomial times a binomial. Now, obviously, these binomials look a little bit unique, right? Because they look exactly the same, but one has addition and one has subtraction. We call these types of binomials conjugates, but that doesn't change anything with the process. So whether you know that word or not, the process stays exactly the same, right? If we have two binomials, we're just going to start distributing. Okay, so same thing today. 2y times 2y gives us a 4y squared. Right, same thing, distribute again. 2y times 7 gives us a positive 14y. And then we'll go on to our second term. So now we'll distribute the negative 7. Negative 7 times 2y gives us a negative 14y. And negative 7 times positive 7 gives us a negative 49. Okay, so now we're here. Just like yesterday, we're going to combine like terms. So if we're combining like terms, we're going to bring down that 4y squared. Okay, a 14y and a negative 14y give us 0. So those just cancel out. We don't even want to write that 0y there. That would be really weird to write 0y. So, right, those are just gone. But we still have this minus 49. So our final answer is just 4y squared minus 49. Okay, now this next one is a little bit more unique. Kind of have to have some info to even get started here. Let's say we have 4w plus 5 squared. Okay, this is a binomial squared, right? We have something with two terms, a binomial, and it's squared. So remember, an exponent tells us how many times to multiply the base by itself. And the base is whatever is receiving the exponent. So in this problem, 4w plus 5 is what is receiving the exponent. So 4w plus 5 is our base, and we want to multiply it by itself twice. So we need to take 4w plus 5 times 4w plus 5. Okay, and once we're there, then we should go, oh yeah, now this just looks like a binomial times a binomial. And so 4w times 4w is going to give me a 16w squared. 4w times 5 is a 20w. Then we'll switch and start distributing the 5. So 5 times 4w is 20w. And 5 times 5 is a 25. And so again, we will just combine our like terms. So 16w squared plus 40w plus 25. Okay, now on this next problem, just write it down. Don't freak out at first. Just take a deep breath. It's going to look bigger. Let's say we have 3x plus 2. And now we're going to multiply this times a trinomial. So 5x squared minus 3x plus 9. Okay, this is larger, right? It's a binomial times a trinomial. But the good news is that the process doesn't change. We're going to do the exact same thing. So we're just going to look at the first term and start distributing. 3x times 5x squared gives us a 15x to the third. 3x times negative 3x will give us a negative 9x squared. 3x times 9 will give us a positive 27x. And then we'll just flip-flop like we've been doing every time. And so I'm going to flip-flop to my second term and do it all over again. So 2 times 5x squared is a 10x squared. So that's a like term with my 9x squared. So I'm going to put a positive 10x squared underneath it. 2 times a negative 3x is going to give me a negative 6x. That's a like term here. And 2 times 9 is not a like term with anything, which gives me an 18. And so now when I go to combine like terms, this looks even more like our adding and subtracting polynomials. So I can just go straight down. So I'll get a 15x to the third plus a 1x squared, or you could just say x squared, that would be fine, plus 21x plus 18. Now, obviously, if you needed to use a calculator to help you with getting those combined or whatever, you could. None of these now have matching exponents, so our final answer is that whole entire thing with all 4 terms.